9.3, solving systems with matrices. You will need a graphing calculator for part of this unit. So if you don't have one, you can always come in and borrow one. All right, so let's start off with our warm-up. We want to multiply T times W, which is what we learned how to do in section 9.2. Remember that we always want to check the dimension, so how many rows by how many columns. This is a 2 by 2, and we're multiplying it times a 2 by 2. To check to see if you can multiply, you look at those middle numbers, and if they're the same, then you can. So we're going to take the first row times the first column in order to be able to multiply. So you can do it visually, or if you would rather write that first row next to it so that's right by the numbers that you're multiplying, that's fine too. We're going to take -1 times 4 plus 3 times -2. So in that first row, first column of our answer, we have -1 times 4 plus 3 times -2. Then we take that same first row and multiply it times the second column. So -1 times 1 plus 3 times 0. Since we're all out of columns to multiply that row by, we go ahead and switch to the second row. So we're going to take 2 and 4 and multiply it times 4 and -2. 2 times 4 plus 4 times -2. And then times the last column. So 2 times 1 plus 4 times 0. All right, simplify all of those and we get -10, 0, -1, 2. Now today we're going to be solving a system by hand using matrices. We'll be able to use some of the skills that we learned how to do in 9.2, like multiplying. What you're going to do is you're going to be given a system, and after you're given that system, step 1 is to write the coefficient matrix and then find the determinant. The determinant is AD minus BC. So notice the placement of these letters. AD going diagonally this way, minus B times C, which is diagonally the other way. Then there's 2 more steps after that. You may need to pause on the video from time to time to get everything written down. No worries, I'll be here when you get back. All right, step 3 is to find the inverse matrix. So we take 1 over the determinant, that's what you found in step 2, and we multiply it times this messed up matrix here. Notice A and D switched places and B and C became the opposite. Then we take that answer and we do step 4. So we multiply the inverse, which is what we just found, by the constant matrix. Constant is different than coefficient. Constant is what your system is equal to, the numbers that don't have variables with them. Let's take a look at number 1. We can walk ourselves through those steps. So step 1 was to write your coefficient matrix. So we're going to take the coefficients of these variables, 4, -5, 2, and -1. Okay, then step 2 is to find the determinant. Remember, determinant is when you take your A times D minus B times C. So we're taking 4 times -1 minus -5 times 2. So 4 plus, sorry, that's a -4, plus 10 is going to give us a determinant of 6. Again, I know I'm going through quickly, so just pause if you have to catch up. All right, step 3, find the inverse. So we're going to take 1 over 6, the number we just found down here, and then we're going to rearrange this matrix. So we're going to switch places with the A and the D, and then we're going to make B and C the opposite. So -5 becomes a +5, and +2 becomes a -2. Now that's not all of finding the inverse, because now we actually have to multiply the 1/6 times each one of those. So 1/6, and leave it as a fraction, so we'd have -1/6, 5/6, and then -2/6, but that could be reduced to -1/3, and 4/6 reduces to 2/3. So that's step 3. And then step 4, we're going to multiply the inverse, so that's what we just found here, by the constant matrix. The constant matrix is the matrix that has 7 and 5 in it. So -1/6, 5/6, this whole inverse matrix here, -1/3, 2/3. We're going to multiply that times the matrix 7, 5. Now remember what we talked about earlier, dimensions have to match. This is 2 by 2, and this one has 2 rows, 1 column. So those middle dimensions do match for us to multiply. So we're going to take this first row times this first column, which is the only column that there is, and we'll have -7/6, oops, forgot my fraction bar there, plus 5/6 times 5 is 25/6. Then we take the second row times this column, so -7/3 plus 10/3, and when we simplify that, we get the matrix 3, 1, which simply equals the ordered pair 3, 1, which means that that system, those two lines, intersect each other at the point 3, 1. All right, so go ahead and see if you can try number 2. Write down the system, put pause, and then see if you can work yourself through those 4 steps. Start by doing your coefficient matrix, the numbers in front of all of those variables. So we have 12, 4, 15, and 5. Then we find our determinant, AD minus BC. So 12 times 5 minus 15 times 4. And that's going to equal 0. So when we try to do step 3 and take 1 divided by 0 times that mixed up matrix, can we divide 1 by 0? No. So if you get a situation like this, you would say the inverse does not exist. So we would not be able to solve this system with matrices. So let's actually try one that we can solve, because that was kind of a anomaly. We don't see that very often, but just every once in a while, I just wanted to show you what happens when we get a determinant of 0. All right, so take a minute and write down number 3. As you're writing it down, please notice that the X's and the Y's are not lined up. So when you go to make your coefficient matrix, you need to flip-flop the X and the Y in that top equation so that when you write your coefficient matrix, your X comes first and then your Y. Otherwise, the whole thing will be messed up. So make sure your X's are always first, then come your Y's. So go ahead and hit pause and see if you can find the determinant, the inverse, and then multiply the inverse times that constant matrix. Then come back and see if you got the same answer that I did. So that was step 1. Step 2 is the determinant. -3 times 2 minus 5 times 3. We get a -21. Step 3, we're finding the inverse. 1 over -21. Switch places with A and D. Opposites on B and C. When we multiply that scalar times that matrix, we get -2 21st, a +5 21st, over 3, that's going to reduce. 3 21st reduces to 1/7. And so is the next one. We're going to multiply that times our constant matrix, which is -5 19. So we're going to have some more fractions here. 10 21st plus 95 21st when we multiply first row times first column. And then -5/7 plus 19/7. Simplify all of that. We'd have 105 divided by 21, which is 5, and 14 divided by 7, which is 2. So that gives us the coordinate point 5, 2 as the intersection of that system. Hope you got that same answer. All right, number 4 is where we need to start using our graphing calculator. So you will definitely need to grab one if you don't have one, because we're going to learn how to solve a 3x3 matrix, but it's with a graphing calculator. So we start the same way. We start by writing the coefficient matrix. So we're going to take all the coefficients here, but since we have 3 variables, our coefficient matrix this time is going to be a 3x3 because we have 3 variables and we have 3 equations. So we have 2, 3, 4 as the coefficients of that first equation. 1, -2, 1. And then this last equation is missing the y, so we'll just put a 0 placeholder in for that coefficient. We're going to call this first matrix, matrix A. And we set up our work by doing matrix A times the variable matrix. X, Y, and Z are the variables that we're using. And it's going to equal our constant matrix, -18, 4, -19. We call the constant matrix, matrix B. Since most of the work will be in your calculator, I'll have to see this on your paper. All right, so the other thing we're going to need to do before we put it in our graphing calculators is know the dimensions. We talked about this having 3 variables and 3 equations. So we can see that this is a 3x3, 3 rows, 3 columns. This one over here, 3 rows, 1 column. So we need to know that for our graphing calculator. All right, so grab a graphing calculator and you are going to start by hitting second, your blue key at the top, and then this X to the -1, you'll see the word matrix right above it. So we hit second matrix, and I'll write these steps down here too. And then you're gonna go to edit. So after you're in second matrix, arrow over to edit. When you hit edit, you're gonna enter the dimensions. So I'm gonna enter 3x3. And when I do that, a 3x3 matrix pops up. Yours might have numbers in it, it might not. But I'm gonna now enter these coefficients into that matrix. So enter each one of those, hit 2 enter, 3 enter, into your calculator. So 2 enter, 3 enter, 4 enter. It goes across in rows. If you just enter them, it'll jump to the next row for you. So when you get all finished, you should have that same matrix, matrix A, with the same numbers in your calculator. When you're done with all of that, hit second quit, so you're back on your main screen. Just kind of gets us out of there for the moment, because we're going to repeat that process. We're going to go through all of this again, except we're going to enter matrix B. So we're going to do second matrix, arrow over to edit, but this time when you're in edit, you're going to arrow down to matrix B instead of matrix A. And then put in 3x1 because matrix B is 3x1. And then enter those constants from matrix B. After you get them all entered, hit second quit again. Now I told you before, like we're doing a lot of work in our calculator, I need to see this as work on your paper. I don't need to see the steps from the calculator. This is just for your reference here. But the other thing I will need to see is the equation we're about ready to type in on our home screen. Okay, it's going to be A inverse B, and that's going to give us our variables x. So I need you to write this on your paper also, so that I know what you're typing in your home screen. And now we're actually going to do it. So you're going to go back to second matrix where we were before. But instead of going over to edit, you're going to select matrix A and just hit enter. And matrix A should show up on your home screen. Then you're going to hit the inverse button. The inverse button is the button that has matrix written right above it. Okay, so that button we've been using. So now your home screen should say A with a -1. Now I need to go back, don't hit enter or anything, go back and get matrix B. So second matrix, arrow down to matrix B, hit enter. So we have A inverse B on our home screen, which is what we also have on our paper. Now we can hit enter, and it gives us the coordinates of the intersection of those three lines, -5, -4, 1. So -5, -4, 1, which represents the ordered triple, -5, -4, 1. And we found ordered triples in our last unit by hand, but thought you would think it'd be pretty cool to find them with a calculator this time. All right, so I'm gonna give you another one. I want you to see if you can do the whole thing, set it up, and put it in your calculator. So go ahead and write down number 5, and then hit pause, work on it, and come back and see if you got it right. All right, so we're gonna start by putting in the coefficients, putting zeros for when there isn't anything. We're going to multiply that times the variable matrix and have it equal the constant matrix. We labeled our original coefficient matrix A, and we're going to label this one B. The other thing, after we get all those entered in our calculator, we're going to use A inverse B to figure out our ordered triple. So hopefully you've already done all of that, and you found that 1, -5, -6 is where these lines intersect. So that is the point 1, -5, -6. All right, last one, number 6, same thing. I want you to write it down, hit pause, and try it, just like we did on number 5. We have some work on our paper, but a lot of work is in that graphing calculator, so practicing those steps. And I really want you to keep going through and practicing those. So on this one, our coefficient matrix would be 1, 2, -3, 3, 5, -8, 1, 1, -2. Times our variable matrix, and it's equal to our constant matrix. Our first one is matrix A, our last one is matrix B, and we're going to use the equation A inverse B to find out our intersection point. Now when you put that in your calculator and you type A inverse B, your calculator will say something to the effect of error singular matrix. What that means for us when we see that error message, one, we could have typed in our numbers wrong. So go back and verify that you typed them incorrectly. One negative left off of one place could give us that error message. But if you typed in everything exactly right and you still get that error message, it means that your lines do not intersect. Okay, so if that is the case, then you can just say they do not intersect. Easy as that. All right, that is all of 9.3. I'll be back with 9.4.